guys, Mrs. Suya here. This is like a set of notes for the B day of section 13.2. It does include some important stuff on here that we didn't go over yesterday. So these are designed to be openers. They just end up taking a long time. So let's leave the openers, at least on this video, till the end. And we're going to get to the important part. And maybe we won't get to the openers. Okay, so there's a section like this on the notes, and we do a lot of this tomorrow as well, so this will help take care of tomorrow's stuff. So we are going to evaluate the trig function. We're going to find the tangent of 150 degrees. We're not going to use a calculator, so this is not about punching it into a calculator. The process we're going to go through is we're going to sketch an angle, draw a perpendicular to the x-axis, label the sides of the triangle, and arrive at an exact answer. All right, so 150 degrees. Let's just have a reminder that this is 0 degrees initial position, 90, 180, 270. All right, so 150 degrees, we're going to rotate past 90, but not all the way to 180. Now, second step is that we are going to create a reference triangle. We did not do stuff like this yesterday on the notes. So the reference triangle, I'm going to erase that and move it up here, I guess, 180. Always gets made down to the x-axis. This is very important. This is like in the beginning of trig, one of the things that students goof up the most. So I am going to drop a perpendicular down to the x-axis, and then I am going to use this as my reference triangle. So I want to do SOHCAHTOA from this triangle. What I need is an angle, though. And angles that we get for SOHCAHTOA, you know, rotating this way, they're always coming from the x-axis, or sorry, from the origin. And I mean, if this is 150, we know that this would have to be 30 degrees to complete the full 180 degree rotation that would take it all the way to here. And so you see that is a 30-degree angle. When you are going to be doing trig without a calculator, what ends up happening is when you rotate these angles, you're always going to be in one of our triangle families, right? This is going to be the 30, 60, 90 family. So you're only going to get a set amount of angles that this happens with. If you, when we get to angles that aren't in the families, then we have a different procedure that we would do. Okay, so once you get this, now you don't have any sides, and so we do have some choices, and depending on, you know, all the answers are going to be the same in the end, but the easiest way to start this, I think, is to always make the short side 1. So the short side in this family is always across from the 30-degree angle, which is important to know because now that you're going to be making your own triangles, sometimes you don't really make them quite right. Okay. Hypotenuse is always double the short leg. Long leg is the one that's whatever the short leg is times the square root of 3. Okay, so the deal is that we're trying to find the tangent of 150 degrees, and currently this triangle is a 30-degree angle. So the thing that makes us do the 150 degrees is to add some signs on here. So in quadrant 2, the x-coordinate is always going to be negative because I've gone left from the origin. Y-coordinate will be positive, and then hypotenuse is always positive. And that's, I mean, we're not really seeing circles today, but we are going to eventually be seeing a lot of circles on tomorrow's worksheet. Okay, so we are just going to do our SOHCAHTOA from this 30-degree angle. Tangent is opposite over adjacent. And adjacent is negative, so we're going to have a negative on this answer. Rationalize. It doesn't matter where the negative ends up, in the denominator or numerator, you just typically bring it right out into the front. And that's the final answer. Okay, let's see. Cosine of 330. So here's our 0, 90. Do this every time if you need to. That way you really learn what the quadrant numbers are. 330. Okay, so we're going to go all the way around and we're going to stop shy of the 360 degree angles, right? So this is 330 degrees. I know this would be another 30 degrees, right, to bring it to full 360. Reference triangle always gets made with the x-axis. So here's my reference triangle. Again, we're at another 30, 60, 90 degree family. I'm going to erase that 360 because I want to put my triangle dimensions here. So short leg across from the 30, that's always 1. Hypotenuse, double the short leg. Long leg is square root 3. Okay, so 1, 2, root 3, that's like a quadrant 1, 30, 60, 90 degree family with a 30 degrees there. The thing that makes us in quadrant 4, or a 330 degree angle, is a negative y value paired with a positive x. Cosine of 330, we're doing our SOHCAHTOA. That's adjacent over hypotenuse. So it is actually the square root of 3 over 2. We don't have a negative on this answer. All right, and then sine of 225. Okay. 0. 90. 180. 270. So we're going to go past the 180, not to the 270. We're down here in quadrant 3. Okay, so don't make your reference triangle over to the y, right? It always goes up to the x. So what we need is this angle right here. This is called a reference angle. So we've gone 180 degrees plus some extra. So we'll just go ahead and take our 225, right? And we're just going to subtract away the 180. And then we'll know the leftover part is however much further we have gone. So minus 45 degrees. All right, so that puts us in the 45, 45, 90. So again, when you do this, you should always end up in one of our families. Otherwise, you can't really do it without a calculator like you're supposed to. Okay, so in this family, we know the legs are going to be, well, we're just going to make them 1 and 1. We use a lot of 1s in trig. And then hypotenuse is square root of 2, right? Whatever the leg is times the square root of 2. Because we're in quadrant 3, the two legs are both negative. Negative 1 and negative 1. So that's what makes us in the 225 degree angle. Even though we're using 45 for our SOHCAHTOA and to set up our triangle, we're still finding the sine of 225 degrees. And we do that by making the sides the correct sign. Okay, so the sine is going to be opposite over hypotenuse. Negative 1 over square root of 2. And now we're going to just rationalize it. I'm off my screen. All right, there we go. Okay, so now we do the same thing, only we're in radians. So, I mean, just for the practice of radians, like one thing you could do is you could convert that to degrees from the get-go and just do it in degrees, but practice radians. So this is like 0 radians, and this is pi radians all the way over here. And this would be like pi over 2, 3 pi over 2. So the trick with radians is, you know, see what that denominator is, and then just make this pi right here be 4 pi over 4, right? That's the same as pi. Okay, so half of that would be 2 pi over 4. So it's kind of like every axis we're going to be counting 2 more pi. So plus 2, 6 pi over 4. 8 pi over 4, that's like 2 pi over 4, or that's just like 2 pi. That's the full rotation. But look, this is 11 pi over 4. So this one is one of those annoying ones. It's gone all the way around, and now, let's see. This would then go up to 2 more, right? 8, 9. So this would be 10 pi over 4. And then all the way over to here would be 12 pi over 4. Another 2 pi on top of 10. 12 pi. So we've stopped like 11 pi over 4 would stop halfway between those two. Okay. So there's our 11 pi over 4 angle. We're going to make our reference triangle down to the x. And so we know that to get all the way down to the axis right here, we need to go to 12 pi over 4. And we're at 11 pi over 4, so we're just shy pi over 4. All right, and again, that's just practice with counting and radians. Once you get that, then you need to do your reference triangle. And so we still probably don't think in radians, but it is one of our triangle families. So maybe at this point, I'd just do a quick conversion, right? 180 over pi. Pi's reduce 4 into 180 is 45 degrees. So this is actually a 45-degree angle there. So this is another 45, 45, 90 triangle like we got on number 3, only we got it this time with radians. All right, so our side labels are going to be 1, 1. Make the legs 1 on this family. Square root of 2. Okay, now we're in quadrant 2. So x has to be negative while y is positive. Hypotenuse always positive. Okay, so the sine of 11 pi over 4, I'm going to just use my little reference triangle, is going to be opposite over hypotenuse, 1 over root 2. And I'm going from this angle right here, right? This 45-degree angle here. Oops, my knuckles are in the way. 45-degree angle here. So then I go root 2 to rationalize, and I get root 2 over 2. All right, cosine of 2 pi over 3. So we're going to kind of use our same trick. 0. That would be pi, but I'm going to do it as 3 pi over 3. So this would be halfway there. It looks weird to say it, but 1.5 pi over 3. And then another, so I'm kind of like counting by 1.5s. 1.5, 1.5. This would be like 4.5 pi over 3. All right, and then 2 pi over 3. So I am going past the, what I call the 90-degree mark. I am going into this quadrant right here. Okay, so this is 2 pi over 3. Right, to get all the way over to here, I would need a full pi over 3. Right? 2 pi over 3, 1 pi over 3 would take me to 3 pi over 3. Reference triangle goes down to the x-axis. Now I've got pi over 3. Which one is that? Is that going to be 30 or 60 or 90? It's one of those, because without a calculator, we're always going to be in one of those triangle families. So pi over 3 times 180 over pi. 3 goes into 180 60 times. And the 2 pi's are going to just reduce. So this is a 60-degree angle right here. 60 degrees. Okay, so here's where you kind of have to be careful, because depending on how good you drew your triangle, mine actually isn't too bad, but the short leg then is this one here, right? Because that would be the 30-degree angle, so short leg would be here. Long leg would be square root 3. Hypotenuse would be 2. Okay, and I'm in quadrant 2 again. So that's going to take me in negative in the x direction, positive in the y. So when I do my cosine, right, that's the SOHCAHTOA, adjacent over hypotenuse is just negative 1/2. Okay, and last one in radians, 13 pi over 4. Okay, so I know that that's like, you know, like we did on number 4 here. That's a full rotation, right? Because a 12 pi, 8 pi over 4 was the full 2 pi rotation. So let's see. I don't know. Should we just do it from the beginning? So this is like our pi, right, which is, and I'm going to write it as 4 pi over 4. So this is like half of that, 2 pi over 4. So I'm counting by 2s, 2, 4. This would be 6, 8, 10, 12 pi over 4. And then this would be 14 pi over 4, right? So 13 pi over 4 is down here in quadrant 3. It's like halfway between the 12 pi and the 14 pi. Okay, so reference triangle goes up to here. So we rotate it around all the way once and then all the way over to here. So this was 13 pi over 4. It's a pi over 4 past 12 pi over 4. And we already figured out that a pi over 4 angle is a 45-degree triangle. So we know this is a 45-degree triangle right here. Okay, and we're in quadrant 3. So we know we're going to have a negative in the x direction and a negative in the y direction. Right, and then square root of 2 for the hypotenuse. So tangent is going to be opposite over adjacent, negative 1 over negative 1. So that's just 1. Come off my screen. That's just 1. All right. Okay, on this next part, the evaluating these trig functions using a calculator seems easy until you see that there's a secant and a cotangent and a cosecant, and our calculators don't actually, in fact, have those keys on them. I don't even think they're buried in, in menus anywhere. So what we're going to do is we're going to remember that the secant was the reciprocal of, and the way I always remember which one is the reciprocal of is secant starts with an S, and it's always the reciprocal of the the one that doesn't match the letter, so cosine in this case. Okay, and that's great. What we did before we had problems like this is, and when we had a triangle, all we did was we found the cosine, then we just flipped the fraction to get the secant. And now we're going to be using those definitions that didn't seem very useful at the time. They're on your 13.1 notes. And we're going to say, hey, the secant is the reciprocal of the cosine. Here is a very straightforward way to write it. The reciprocal of the cosine just means we're going to take our cosine and flip it, write it 1 over the cosine of, and then we're going to do 164. And we'll just kind of put it in our calculator right like that, right? 1 divided by cosine 164. And we get negative 1.0403. Negative 412 degrees. We know a cotangent is the reciprocal of a tangent, so we're just going to write it 1 over tangent of negative 412 and figure that out. I mean, it's also kind of a cool time to talk about the fact that your calculator does in fact do radian measures, but it's always kind of awkward because it does radians with the pi already multiplied out for it, so it's not like you ever see the pi when you do it. Anyway, this 412 is in degrees, so we are going to do 1 divided by tangent of negative 412. And we get negative 0.7813. All right, and cosecant is 1 over the sine of 300. All right, 1 divided by sine, oops, of 300. My calculator was probably off the screen. I wasn't paying attention. 1 over sine of 300. Negative 1.1547.